Okay, so I'm bringing you to the ALMA Science portal now. And in the rest of the time, I propose that we build a proposal together. So I guess if you are here, is that you are planning to submit a proposal for this cycle. The new thing is that the observing tool, that is the tool that is used to submit the ALMA proposal, has changed. So before it was a software that you had to install in your own computer. So this is not the case anymore. Now it's a new tool that is web-based, that is online. So that means that the first thing you need to work on your ALMA proposal is to have an internet connection first. The second thing, of course, is that you need to have an ALMA account. Okay, so I guess that probably most of you already have one. And then where you need to go to this ALMA Science portal here. You can see my mouse, by the way.
Yes.
Yes, okay, perfect. So if you go in this proposing here, you have this here observing tool. If you click, then that's a place you have to go to submit your proposal. So this is the button that you have to click on. I just would like to point out that there are several video tutorials if you would like to have a look there, and also the big user manual that contains everything you want to know about the proposals and ALMA there. There's a lot of information there. And of course, you're welcome to ask us questions anytime. Until the deadline, we are here to help you, right? Okay. So I'm clicking here to start the web tool. I want to say something very important now, is that you will start to build your proposal. You will start to invite co-Is. What I want to say is that all the co-Is will have writing permission to the proposal. So it means that you have to be very careful with your team. You need to be very organized and very well coordinated, that not people not confuse or make mistakes in the proposal. So if you start to edit all at the same time, it's going to be a big mess. So PI, I think, should take the responsibility and be careful about this. PI should coordinate the activity. Okay, so this is really the new thing here. Okay, so when you start this observing tool, then you have the possibility to do several things. So I guess the first one will be most interesting would be to create a new proposal, but you also can retrieve project from the server, or you can open all proposal or project as a new proposal there. Okay, so for the moment, I will just create a new one. Okay. And so basically, for those of you who have used the observing tool before, it's basically the same philosophy that you enter the fields and all the information, the relevant information for your proposal. And just like the design is a little bit different, colors are different, but more or less it's basically the same things. So you should not be totally lost. Okay, so there are basically two parts. And the first one you see here is a noted proposal. This is more or less the administrative part, where you have to enter all the information on your proposals, the co-Is, of course, the science goals and everything. And the second part is more the design of the observation, with really the technical aspects and all information for the array itself. So what I suggest is I just go through all the fields. I will not build a real proposal. I will just do a fake one, but just go through the fields. And if you have any questions, just stop me on the way, and I will try to answer. But I will try slowly to build a proposal as I would do if it was a real proposal. So you need to have like a title first. So be careful of this on the title, because if you have several proposals, then you will have a list when you enter. So if you don't make clear names, maybe you get very quickly lost. So make a clear names on your titles. For example, don't write fake proposals. Don't do like this, but really put really good names. Okay, fake proposal. No, whatever. Don't do this, but okay, this is the idea. You will have to submit to write an abstract as usual. Okay. So we're not writing any other science thing, but okay. When the field is appeared, say it should appear in green around here. But for example, here, if I'm okay, no, it doesn't mean. If I'm over 100 and 200 characters, for example, it's going to appear in red here, and you will see that something is wrong. Okay, so that's the way you see in the fields. Okay, so you have different types of proposal. So for this call of for the deadline, it would be like well, it can be regular, like a normal proposal, or it can be a target for opportunity if you want to apply time in case of an event is happening. For example, like if there's a supernova exploding, and then you would like to observe, or it can be also VLBI or large program here or phase array. So you can choose. So I guess most of people are using this regular thing here. So you have different scientific categories like cosmology, galaxies, ISM, young stellar objects, and evolved stars, basically, and the sun. Okay. And once you choose this, and you have a list of keywords, and you can select two of them, and then I just pick up two random here, but you have to click on one, and then if you want to click on the second one, you click on the control button, control in your computer, and you can select a second one. But I think this is pretty much standard. So one of the interesting things about the possibility to have joint proposals. So for example, if you want to apply in the same time, if you want to apply also for time with the GWST or with the VLT or with the VLA, then you will have to click on yes here. Then you will have to choose which facility here. And you have to specify if it, which one will be the main facility. So, and this is defined by where you ask for the largest observing time. So if you ask 20 hours for ALMA, for example, and only 1 hour with the VLT, that's going to be ALMA as the main, and in this case, the VLT will be the partner. And here you will have to answer to enter some specifics about technical justification. So it's not a proposal that you have to put here, but like at least a summary of what you request on the other facility. So probably the observing time, the sensitivity, the resolution, and that kind of information there. Okay, but at the moment I would say no, I don't want to join proposal. Okay, the next thing is about investigators, so that's more or less easy. Also, you can invite co-Is as you want. The only important thing is to designate a reviewer. So if you submit an ALMA proposal, it means that you commit in exchange to review 10 proposals in the peer review process. So it means you need to have a reviewer here. So it can be you, and by default, it should be you as a PI, I guess. But you also can promote someone else if they agree to be the reviewer for you. So you can choose who will be the reviewer. So the important thing is that they want to know if the reviewer has a PhD, and if not, if it's like, for example, a student, then you will need to enter a mentor name here. But okay, just like normal things here. The most important thing in your proposal, of course, is the science case. The pressure is very high, so you have to be very convincing and to have like very exciting science. So this is here, you enter your beautiful 4 pages PDF. Okay, so this is the most important part. So work hard and well on this one. So you can view, attach, and then you can remove and update as you want here. And the last item on this page is about duplicate observations. So in principle, ALMA will not allow you to do observations that are already been done. So if the data are already in the archives, in principle, there's no need to re-observe again, right? Except, for example, if it's like a variable object, a variable source or something like this. So in principle, is the responsibility of the PI to check in the archive that the observation are not been done. And actually not only in the archive, but also, that's important, also in the list of A projects that are in the queue now. And if you want to check this, there's a link here for duplications. So I can show you. I hope it's going to... Is it staying in the same page? Are you still with me now in these duplicate observations, or?
Yeah.
You didn't? Okay, I was afraid it was opening a new window. Perfect.
Oh.
So here you are. So it's explaining a little bit more about these duplicate observations, but you have an access to the ALMA archive, so you can search in the archive for duplications. But you also have a list of all these A-ranked proposals, and I think it's the B and C that have already been started. You have this list in this queue in the form of an Excel spreadsheet here. So it can be quite a long list. So you actually have like a Python script that is proposed. I think it's nothing really official, but there's just something to try to help you. You can have a possibility to query the list using this Python script here. Okay. But if you have any question about the application, of course, always you can contact us anytime anyway. Okay, now I would like to go back. I've lost where I am now. Can I go back? Why is it? Oh, no, it's just here. Okay, perfect. So are you back with me in the observing tool?
Yes.
Perfect. Wonderful. Okay, so this is more or less the first page. All this information, I think, is more or less easy to understand and easy to fill in. So now maybe we can spend a little bit more time now on the what they call the science plan, which is more like the technical information. And this is where the things come interesting there. Okay, so basically what you have to do is to specify what source you want to observe and what technical setting you want for the array. Okay, so first, this is created by science goals. And to define a science goal, I think I would say is like one set of targets that can be observed with the same calibration, with the same angular resolution, and with the same sensitivity. So that defines the science goal. If you have, and the same band, sorry, also the same ALMA band. So if you want to observe in ALMA band 1 and ALMA band 4, for example, that would be two separate science goals. Okay. Okay, so you can create and remove and delete science goals as you want. So here I have the first one already, and here are all the information that you will need to enter. So you can just put some description. I think this is more or less for you to not to be lost in the case you have many science goals. I think it's good to have clear titles here. Okay. And first I will go to the field, so the source setup. So you already have one source, fake source here. I think you can add more. So you can copy, you can delete more, as you want. So here I propose to observe a starburst galaxy. I would just put NGC 253 as an example because I think it's beautiful. I propose that we target, CO 322, but in redshift 1, just to show you some example. I suggest we use a 0.1 octagon resolution, and then, okay, we try to make a proposal with this. So the first thing, you can retrieve the name of your source, and this is in the Simbad database, so they should follow the correct syntax here. So you can go there and try to resolve your source. So this is very nice that they issue this warning here, because I want to tell you that it's very important that you double check the coordinates, and especially the velocity or the redshift here, because at the end is again also of course the responsibility of the PI that all these information are correct, and that's what you want to observe here. So let's say we are happy with this at the moment, so I can select. So you see here you have this image that appears, so that's the field of view. I guess it's in optical. Probably you can change the layout behind. So you have this coordinates information here. And here I would just like to change, just for fun, just to put a redshift of 1. One thing you should notice is when you enter information here, until you click out, if I click out, then the information is correctly entered. If you press enter, nothing will happen. You know, I'm pressing enter in my computer, but nothing happened. If you want to do the equivalent, then you have to press tab. And then if you press tab, then it's going to really input the file. So sometimes it can be a little bit confusing if you're not used to. So sometimes I make the mistake also. But otherwise, just the easy way is just to click outside of the field to make sure that the information is correctly passed there. If there's something wrong, it should always appear in red also. Okay. No, I would just like to can I put a number here? Yes. No, I cannot. Shit. What happened? Yeah, sometimes I have unpredictable behavior here. Okay, I will come back to it. I cannot change the number here. I will show you later how to do mosaics and things like this, but we need to define the frequency, but here it has to be done in the spectral setup now. I will come back here. You need to enter several more properties for your source, like the peak continuum flux, the line flux. So maybe I can just input some fake values again here, but okay. You need to enter line width if you want to observe spectral lines. If you're not interested in polarization whatsoever, then you can just leave the other things as a 0, 0, and that's fine. But if you want to do polarization information, polarization observation, then you need to enter the correct properties of the source in there. Okay. If you want to observe more sources, it's also possible to import a list of sources. And if you really want to observe like hundreds of sources, maybe it's much easier to do this rather than entering all the sources one by one. So you can import a list. So it has to be in the correct format. And I can show you later if you want, or you can check. You can find the information into the OT observing tool user manual there. I think this can make your life much easier in case you have a lot of different sources. Okay, so I keep one pointing at the center at the moment. I will come back just later to set up a mosaic here, but I need to fix the frequency first to fix the thing. So then I will go next to the spectral setup. Okay. Okay, I just mentioned here that you can quit the observing tool now. You can close your internet. You can go to have a walk or to have a lunch or whatever, and you come back. You reopen. You reload. Then you should find exactly the same project as it's saved in the web-based system, right? So I think this needless to say, but okay, better to just to mention. That's the nice thing about this web-based thing. Okay, so here this is the figure showing all the ALMA bands here, and we can enter up to 4 spectral baseband here. So you can enter them by query a spectral line in the database that we do now, or you also can enter them manually here. So first, I will just select, for example, I want to observe the CO322, so I will just select or search for the CO line in the database. So usually I try to do like something like this. You can enter any molecules, and it's searching in the database now. It's searching. You have to be sometimes a little bit patient. I hope something is going to come. Yes, there it is. Now I want CO. Okay. Not very nice what I get. I want CO, CO, CO. Can I put more things? Yeah. I need to click out always, yes. I always have problems with this. You should find what's there in the list or what. There we are. I don't know what was happening before, but now I have my CO lines. So I say just for fun, I would like to go for the CO 322. So you see here the rest frequency and here the sky frequency. That's why I put a redshift, because in this case it can be different. So be careful. Rest frequency, sky frequency is not the same thing, right? So this is the sky frequency is the rest frequency divided by 1 plus z. So that's why I put z equal 1, that we have like a factor of 2 in the 2. Yeah. So if I'm happy with that one, that's the one I want to select. I double click. Now it's selected. And I can select more if I want, but then I can save this one. And then the first one, it's selected for the first baseband here. So I can put here a lot of different spectral modes. So you can go from the very narrow bandwidth with a very, very high velocity resolution, or up to like a broad bandwidth, but with like intermediate velocity resolution here. So we can have like 0.0 something kilometer per second to 2 kilometer per second. So those are the spectral line mode, I would say. And you have like a continuum mode that is the broad one with very, very coarse spectral resolution here. So this is if you want to do continuum observation or if you have very, very broad lines. And I would say if you have very narrow lines, you should use something like this with the correct velocity resolution to resolve your line. Or if you want like say like a standard way, you can just use these broad spectral line windows here. So I double click. And now I see here, if I zoom to the bend here, you see now that I have like this spectral window set up here. So now with ALMA, we can have up to up to 4 spectral windows. So I can put more basebands here. So then I will just add by hand. I will specify in the in sky frequency. I think it's much easier. So I can put one, for example, at 170 megahertz. I can call it line 2. I can get it the same spectral resolution. And then you can see now I have those 2 spectral windows. So you see now that I have this yellow range. That's what Daniel was mentioning before. Those are the IF, the intermediate frequency range. So it means you can allocate spectral windows within these yellow regions here. Okay. And of course, the 2 yellow regions have to be inside the ALMA bands. If you want to zoom in, you do this with the mouse. So you select with the left button, you cover like this, and it's going to zoom out for this part. And if you want to go back to the original, you can zoom back to the band here, okay? Go like this. So now I have 1 spectral window here, another one here, and then just for the beauty, I will put 2 more here. So I can set up one. So here you see the sky frequency and the rest frequency here. So I will put 1 spectral window to cover like almost 2 gigahertz here and another one here just to complete the setup. So I'll put something like 183. I can add here, so I can put 183 in the sky frequency. I can call it line 23. Okay, and the one I can put like 185. That will be line 4. And the same. So of course you can, all the different baseband can have different spectral resolution. Okay, so if you have a look now, so back, now I have my 4 spectral windows here. And one thing that is very important is to set up what is the representative frequency. That is the one frequency that is important for you. So you should put this for your main line of interest. This is where you will specify both the resolution and the sensitivity. So I choose this example because you have to be careful with the atmospheric transmission. So here, this curve here is the atmospheric transmission. So you see that here is quite high, but here you have like an absorption line. So the atmosphere is not good at all here. So if you put your representative frequency here, you're going to need a lot of time to achieve a given sensitivity. But if you put your sensitivity for this frequency is totally different. So very, very careful where you set up your representative frequency. So this you can see by moving a little bit this cursor here. So you have like at the extreme right here, you can see this representative window. This is what I select here. So if I choose that one instead, so you see that it become black here. Now I have chosen this one. Okay, and it changed it will make a huge impact on your sensitivity and when you do the calculation for the observing time. So be careful how you choose the representative window. Okay, so if you have no question on the correlator setup, maybe I should mention, you have different things that you want to do. So I do this like a typical case for spectral line, but you can also just do like the simple continuum, or you also can do a spectral scan. And in this case, you will just specify the start frequency and the end frequency, and you can have up to 5 different tunings to cover a consecutive range of frequency. I think I can just show very quickly how it's done. So if I want to do the same, starting, let's say, from 170 gigahertz to, let's say, 180 gigahertz, if I can do this, yes. So, okay, so this is going to be done like with a spectral scan like this with 3 different tunings. And you have the list of the tunings below here. And this is the mode to do some kind of shallow spectral scan, I would say, like easy in one shot, you will get all this done. Okay, so if I switch back, I hope I get my previous tuning. Yes, perfect. Okay, so now I have, I think, a good correlator setup. I want to emphasize that it's very important that you put enough of these broad spectral windows, because this means that you will ensure a good calibration. And if your source is bright enough, you will have also a good, for the continuum, or for example, you can also have a good sensitivity to do self-calibration on your source. So don't put only very narrow spectral windows here, because you will have much less sensitivity otherwise. So at least keep several of these broad bands to cover enough frequency coverage. Okay, so now I will go back to the source, and I would like just to show you how to set up a mosaic. Okay, so now finally I have this representative frequency set here. And now it means that I have the antenna beam size, the primary field of view that is defined now. So the lambda over the diameter of the antenna. So now you see this by the red circle here. So this is the one-shot field of view. If you want to make a mosaic, in the previous OT, you could draw a rectangle, you could move it. It was very easy, but at the moment it is not implemented yet. So you have to enter the mosaic by hand. Oops. So you can do this here first by selecting, I want a rectangular field, okay? And then you specify here the information here. So let's say I want like something like 70 by 70 arc seconds. And now you see the rectangle here. And then if you click here, you will see all the different pointings here of the mosaic. I think you can set up a mosaic up to 150 pointings now. So I don't know exactly how much it covers, it depends on the frequencies, but you have a maximum of 150 pointings. So here you can check the number of pointings that are done, that are necessary to cover the mosaic that you want. And then you can, if you want, you can twist it or turn it like a different position angle. And so if I want to turn it a little bit, okay, now you see that it has been oriented slightly differently now. So it's not nothing is difficult here. It's just that you need to enter the things by hand in this one here. Be careful about if you enter things by hand, if you want coordinates to be relative or absolute. So just make sure that everything is consistent and don't make mistakes here, because it's a pity if your ALMA is pointed to something that you don't want to observe. So be careful here on the things you want to observe here also. Okay, so now we have our source. We have a beautiful mosaic. We have a beautiful correlator setup. So now actually the most important, okay, well, first I should mention here, this step is very easy. I say just don't touch it. It's about the calibration thing. And I strongly advise that just use the standard system-defined calibration. So unless you really know that you want to do something very special and you want to do and to define the calibration yourself, and then in this case, you really need to have a very good justification and really know what you want to do. Or for example, if you want to have a extra accuracy on the astrometry, then you have to click this. But otherwise, I would say for maybe 99% of the proposals, I think the standard calibration would be the best and just enough. And if you want to use one of these special mode, I strongly advise you to maybe to contact us and to check, and we maybe also can help here. Okay, So now this is maybe the most important part in the proposal, is where you have to enter actually the three most important numbers that are the angular resolution, number one, the maximum recoverable scale, so that is the sensitivity to the extended emission, number two, and the sensitivity of your observation, number three. Okay. So this is where you do this. So first is the resolution. I would like to point out now, if you look a little bit up here, you have this button. If I click here on the right of the window, you see a list of angular resolution. Do you see this list here? I hope you can.
Yes.
So for example, if you click on one given configuration, so this is more like, for example, the configuration 3, and you get for different declinations, you get the minimum angular resolution, the maximum angular resolution, the beam, and the recoverable scale. So that is the extent of largest emission that you can recover. So that is very useful to give you some ideas here. Okay. So this is for one configuration. So sometimes it can give you some ideas. Okay. So let's say I want to have like my mosaic now. You can specify a range of angular resolution, or you can just specify, for example, I want to have, let's say I want to have really 0.1 arcsegons. You can do this. But if you allow for a range, for example, like this, then you will be more flexible for the configuration, and maybe you will have more chance to get scheduled in the observations. So if your science goals can work with a range of angular resolution, then you can maximize the chance to get observations here. Or if you don't care about the resolution, for example, you want to observe a point source, then you can just click on any here. Or if you want to have low resolution and just use the compact array, you can click here. Okay, so this is the angular resolution. Okay, then you have to specify what is the largest angular scale that you want. Let's say if I want to have like if I want to retrieve all the extended emission up to 10 arcsegons, I would do like this. And let's say I want to do this with a sensitivity of 0.1. I'll put it in Kelvin. Just okay. No, I want Kelvin here. No, I need the same problem as. Okay, I get. Otherwise, I have a problem with the calculation. Okay, I'll put 1 million scale. The moment I will change data. Yes, I can get something. Okay. Okay, so after you enter your resolution, largest angular scale, and the sensitivity, then you can go to check what will be the time estimate for your observation. Okay, I have something wrong. What do I miss? No array configuration can be determined. Yeah, okay, that's why. Okay, of course. Okay, so I do this. That I think that is not possible to do this because there's too much difference between the resolution and the maximum recoverable scale. So I will need a very compact and a very extended, and there's a limit of what is possible. So I think there it is. Okay, so let's change this and let's. Yes, now I can get something. Okay, so based on this, now you can see what is required by the for the observation. So it says that in this case, I would need 2 configurations to achieve my goals, and I would need quite a lot of observing time, 1 day. So maybe I was a little bit too optimistic on the sensitivity, I think. But anyway, it gives you a list, breakout of the overheads, the pointing and things like this. How many times the science goal would have to be executed. So of course, this is kind of a heavy one, so probably not a good idea. And the breakdown of all the different calibration. So I think I will change back here. I will just try to get something. I think I was working well with 0.1 Kelvin. So let's try if I can change this now. Okay, and then I want in my example, I wanted to have this. Then I'll put 1 arc second, sorry. Okay. I guess now it should be okay. There we are. Okay, so now I change a little bit. So you see probably that you will need to tweak a little bit what you want to do with good numbers, not just like stupid numbers I'm entering, but what you need really for your science. Okay, and then, for example, here you will say that you need one configuration with a 12-meter array and one configuration with a 7-meter array, with your compact array here, okay? One thing I would like to draw your attention is this configuration. There will be a schedule of the configuration through the year with a calendar. The calendar is written in the call for proposal somewhere. And for example, if you need the most extended configuration, they will be offered only during the summer months, like June, July, typically in Chile. So if your source correspond to this LST, it's okay, but maybe your source cannot be observed in that time. So then you have to check that the required configuration is available with the correct LST range for your source. So that you can check. Okay, so here you have the observation details. One thing I want to tell you also is that the sensitivity is going to be very, very sensitive. That's the case to say it. So it depends a lot on the beam that you put. If you change your resolution here by factor 2, it puts a factor 4 like to the square on the observing time for the sensitivity. Okay, because it's the beam, so it's the surface of the beam that's sensitive. So if you change your beam by factor 2, it affect the observing time by factor 4. So it's very fast here. So don't change too much on the sensitivity here. It can change quite a lot. Okay, and then you have like some other informations. If you want to have the simultaneous observation between the 12-meter and the ACA, or if you want to have a time constraint, if you want to like to do some monitoring or things like this, and then you can enter the date with time windows and things like this in here. And once you are satisfied with this, then you will have to enter the technical justification to justify why you need these numbers. I will just show you here. If I can have it. So you see, for example, I strongly advise you to make the proposal not the day of the deadline, but way in advance, because I guess like it's going to be interesting. Maybe the load on the web-based tool will be very high closer to the deadline. So please prepare your proposal well in advance. Okay. So the few information that you will have to enter depends on your setting, but at the very least, you will have to justify your sensitivity. Okay, so you will need to give some scientific arguments why you need to I need to detect my line with I don't know what. With a signal to noise ratio of 10 or I don't know, something like this, with a good justification. Okay, maybe better than this, you need to have at least 50 characters. So just this is not enough to justify. Okay, you will need to justify why you need this resolution. So, for example, you can say we need to resolve the two sources at the nuclei of a galaxy, or I don't know what. We need to justify again. The source, I don't know what, galaxy or whatever. And you will need to justify why you need this spectral resolution and how you place your spectral windows. And for example, you can say something about the self-calibration here, or you can say you want to have like continuum and line or things like this here. Okay, so suppose now you are happy with all the setup in your observation. So before to submit, you will have to actually validate just to check that there's no mistake in your proposal. And this is just this button validate here. So if I click, so it's going to be checked everything. And of course, I have some errors. Okay, for example, this one is easy to do. So you just double click on the arrow and it will bring you to the correct field here. So reviewer as a PhD. Yes, I have one. And now if I validate again, this mistake will disappear and I can go to the next one and so on. So free. So I didn't put the PDF for the science case, of course. So of course this is a big part missing. What is this one? Spectral window. Okay, and this is what I was mentioning here. So be careful here. Where is my zoom to the? Yeah. Okay, just this mistake is just to tell you that be careful. You set up a spectral window here. That is probably not a good idea to set up because it's a very bad transmission here. So it's probably better to remove this one. Okay. But anyway, and then once you have no errors left, then you can just submit your project here. I'm not going to do it now, but you can just submit and then you get your project in the database. And you can still reopen it and resubmit it until the deadline. So I think I've covered all the steps.